Hello viewers, in today's session we are going to discuss another important problem from beta and gamma functions, and here with the help of the concept of beta and gamma function we are going to evaluate this integral. So here we have to evaluate the integral that is from 0 to infinity, and we have a dx over 1 plus x raised to 4 to the whole power, that is 3, right? So here we have the integrand as 1 over cube of 1 plus x raised to 4. So in order to evaluate this integral, we have to make use of some concepts from beta and gamma functions, right? So here first we'll make use of the method of substitution to convert this integral into a beta function, and then we'll make use of the relationship between beta function and gamma function, and then we'll also make use of the famous Euler's reflection formula, right? So let us call this integral as I, and let us make this substitution, that is t is equal to x raised to 4, so that we have x is equal to t raised to 1 over 4. So now let us differentiate x with respect to t. So we have a dx over dt, and here we have a d by dt of t raised to 1 over 4. The derivative of t raised to 1 over 4 with respect to t is given by 1 over 4, and here we have t raised to 1 over 4 minus 1, that is 1 over 4, t raised to minus 3 over 4. So now we can write dx is equal to 1 over 4 t raised to minus 3 over 4, and here we have dt. So now let us change the limits accordingly. So here the lower limit is 0. So when x is equal to 0, the value of t can be obtained from this relation. So now when x is equal to 0, the value of t is also equal to 0, and when x tends to infinity, then from this relation we can see that t also approaches to infinity, right? So now let us write this integral in terms of t. So we can now write I is equal to the limits from 0 to infinity, the limits remains the same, and for dx we can now write 1 over 4 t raised to minus 3 over 4 dt, and here we have 1 plus t raised to 3, right? So now let us simplify it. So we have 1 over 4 outside the integral, then we have 0 to infinity, and we have t raised to minus 3 over 4, and here we have a dt, and here we have 1 plus t raised to 3. So now let us try to write this integral into this form, that is beta function is defined as beta of m comma n, that is given by this integral 0 to infinity, and here we have say t raised to m minus 1 dt, and here we have 1 plus t raised to m plus n, where m and n are greater than 0. So now if we compare this integral with this one, then here we have t raised to minus 3 over 4. Here we have t raised to m minus 1. So we can compare the exponents here to get the value of m and n. So we have m minus 1 is equal to minus 3 over 4. And here we have 1 plus t raised to 3. And here we have m plus n. So we can write m plus n is equal to 3. So from this equation, we have m is equal to minus 3 over 4 plus 1. that is minus 3 plus 4 over 4, that is 1 over 4. Now taking m is equal to 1 over 4 in this equation, we have n is equal to 3 minus m, and here we have 3 minus 1 over 4, that is 12 minus 1 over 4, that is 11 over 4, right? So now we can write this integral as 1 over 4, and here we have 0 to infinity, and t raised to minus 3 over 4 can be written as m minus 1, and m is 1 over 4. So we have t raised to 1 over 4 minus 1 dt, and here we have 1 plus t raised to 3. Now 3 can be written as m plus n. M is 1 over 4, and n is 11 over 4. So now this integral is our beta function. So we can now write 1 over 4, and beta m comma n. M is 1 over 4, and here we have 11 over 4, right? So now the value of this integral can be given by this expression. So now here we'll convert this beta function into gamma function by making use of the relationship between beta function and gamma function. So beta function is given by beta m comma n. Here we have gamma m, then we have gamma n divided by gamma m plus n. So here we have 1 over 4, then we have gamma 1 over 4, gamma 11 over 4, and here we have gamma m plus n. M plus n is given by 3. So now let us write the value of gamma 11 over 4 by using this relation, that is gamma n plus 1 is given by n times gamma n. So here we can now split 11 over 4 as 1, that is 7 over 4 plus 1, because 7 plus 4 is 11, and we have 11 over 4. So now here the value of n is now 7 over 4. So with the help of this relation, we can now write 7 over 4, and here we have gamma 7 over 4. So now let us again make use of this result, and 7 over 4 can be written as 3 over 4 plus 1. So now let us again apply this rule. Now the value of n is 3 over 4. So we have 3 over 4, and here we have gamma 3 over 4. So now this is 7 times 3 is 21. Here we have 16, and gamma 3 over 4, right? So now the value of gamma 11 over 4 can be written in terms of gamma 3 over 4. Now here we have gamma 3. Now gamma 3 can be written as gamma 2 plus 1, that is equal to 2 factorial, and 2 factorial is 2 times 1, that is 2. So here we have used this result, that is gamma n plus 1 is equal to n factorial, right? So now substituting the values of gamma 11 over 4 and gamma 3 in this expression, the value of the integral can now be written as 1 over 4. Here we have gamma 1 over 4, and for gamma 11 over 4 we have gamma 3. Here we can now write 21 over 16, and gamma 3 over 4, and in the denominator we have 2. So now we can write the integral I as 1 over 4. Here we have 21 over 16, and here we have half, and here we have gamma 1 over 4, and here we have gamma 3 over 4, and gamma 3 over 4 can be written as 1 minus 1 over 4, because 1 minus 1 over 4 is equal to 3 over 4. So now the value of this expression can be obtained by using Euler's reflection formula, that is gamma n times gamma 1 minus n is equal to pi divided by sine n pi. So taking n is equal to 1 over 4, we have gamma 1 over 4, gamma 1 minus 1 over 4 is equal to pi divided by sine pi over 4, taking n is equal to 1 over 4. So now the value of sine pi by 4 is 1 over square root of 2. That is now pi times square root of 2. So here we have taken n is equal to 1 over 4. So here we have sine n pi, taking n is equal to 1 by 4. We have pi over 4. So now the value of this integral I is 1 over 4 times 21 over 16 times 1 over 2, and here we have pi times square root of 2. So now simplifying this expression, so now here we have 21 pi times square root of 2, and 4 times 16 times 2 is 128, right? So viewers, the value of this integral is given by 21 pi times square root of 2 divided by 128. Hello viewers, in today's session we are going to discuss another important problem from beta and gamma functions. So here in this session we are going to evaluate this integral using the concept of beta and gamma functions. So we have to evaluate this integral 0 to infinity, and we have 1 over 1 plus x square raised to 4 and dx, right? So in order to evaluate this integral, we have to make use of some properties of beta and gamma functions. So let us start. So let us first call this integral as I, and let us first convert this integral into beta function by making this substitution, that is x square is equal to t. So we'll make this substitution, x square is equal to t, that is x is equal to square root of t. Now let us differentiate x with respect to t. So we have dx over dt is equal to d by dt of square root of t, and here the derivative of square root of t with respect to t is 1 over 2 times square root of t. So here we have used this result, that is the derivative of t raised to n with respect to t is n times t raised to n minus 1. So here the value of n is half, right? So we have now dx is equal to dt divided by here 2 times square root of t. So now let us change the limits accordingly. So here x varies from 0 to infinity, right? So the lower limit is 0, the upper limit is infinity. So when x is 0, then the value of t is also equal to 0, right? And when x tends to infinity, then t also tends to infinity, right? So now let us change this integral into the terms of t. So we have this integral in terms of t as 0 to infinity, and here we have 1 over 1 plus t raised to 4, and for dx we can now write here dt divided by 2 times square root of t. So now taking half outside the integral, we have half 0 to infinity, and taking t raised to half to the numerator, we have t raised to minus half, and here we have 1 plus t raised to 4, and here we have dt, right? So now let us consider this integral, and now let us define the beta function. Now beta function is defined as beta of m comma n is given by this integral, that is 0 to 1, and we have x raised to m minus 1, 1 minus x raised to n minus 1 dx, where m and n are greater than 0. So beta function is also defined as beta of m comma n is given by this integral, that is 0 to infinity, and we have x raised to m minus 1, and here we have 1 plus x raised to m plus n, and here we have dx, right? So here we'll make use of this result, right? Now this integral is identical to this one, right? So here the variable is t, and here the variable is x, right? So here t raised to minus half, and here we have 1 plus t raised to 4. So here we have x raised to m minus 1, here we have 1 plus x raised to m plus n. So now if we compare this integral with this one, then we can now write m minus 1 is equal to minus half, right? And m plus n can be written as 4. So let us find out the values of m and n from these two equations. So from here we have m is equal to minus half plus 1, that is simply half, and from here we have the value of n as 4 minus m, that is 4 minus half, that is 8 minus 1 over 2, that is 7 over 2, right? So the value of m is half, and the value of n is 7 over 2. So now we can express this integral as here we have the factor half, and we can now write 0 to infinity, and t raised to minus half can be written as m minus 1. M is half, so we have half minus 1 divided by 1 plus t raised to 4. 4 can be written as m plus n. So here we have half plus 7 over 2. So now this integral is our beta function. So we can now write here half, and here we have beta of m comma n, and m is half and n is 7 over 2. So now the value of our integral I is equal to half times the beta function, that is beta of half, and here we have 7 over 2. So now we have to find out the value of this beta function using the relationship between beta function and gamma function. So now beta function and gamma function are related by this expression, that is here we have gamma m, then we have gamma n divided by gamma of m plus n, right? So here we have the integral I, and we have half, and the value of m is half, and the value of n is 7 over 2. So we have now here gamma of m, that is gamma half, then we have gamma 7 over 2 divided by gamma m plus n, that is half plus 7 over 2. So this is half, and here gamma half can be written as square root of pi, because the value of gamma half is square root of pi. And here we have gamma 7 over 2, right? Now gamma 7 over 2 can be expressed as gamma 1 plus 5 over 2, right? That is a gamma of 5 over 2 plus 1. And now using this result, that is gamma n plus 1 is given by n times gamma n, right? So here the value of n is 5 over 2. So we have 5 over 2 and gamma 5 over 2. Now further we can split gamma 5 over 2 as 3 by 2 plus 1, and again applying this result we have 5 over 2, and here now the value of n is 3 over 2, so we have 3 over 2 and gamma 3 over 2. So now this is 15 over 4, and gamma 3 over 2 can be written as half plus 1, right? And again applying this result, right? So we have 15 over 4, and now the value of n is half, so we have half times gamma half. Now gamma half is square root of pi. So now the value of gamma 7 over 2 is given by, here we have 15 over 8, and here we have square root of pi for gamma half. So now here we can substitute the value of gamma 7 over 2 as 15 over 8 times square root of pi, and in the denominator we have gamma 7 plus 1 8, 8 over 2 is 4, and again using this result gamma n plus 1 is given by n factorial. So here gamma 4 is gamma 3 plus 1, that is 3 factorial. The value of n is 3. So 3 factorial is 3 times 2 times 1, that is equal to 6. So here we have 6. So now we can solve this expression. So here square root of pi times square root of pi is pi. Here we have 15, and here we have 2 times 8 times 6. So now here we have 3 times 5 is 15. This is 3 times 2 is 6. So we have 5 pi divided by this is 2 times 8, 16 times 2 is 32, right? So the value of this integral is equal to 5 pi divided by 32. So viewers, this is how by the application of beta and gamma functions we can easily evaluate integrals of this type.